Welcome, class. Thank you for joining me for our second day of this pre-Chapter 10 work. So, to start off with, let's just review how to simplify those radicals we were talking about yesterday. Now, when it comes to simplifying these radicals, remember the key numbers we're looking at are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, so on and so forth, those perfect squares. That is the key to simplifying all of these radicals, is we need to see which perfect square comes out. So for example, when it says simplify the square root of 45, what we're talking about is breaking that down into the 9 and 5, because the 9 is on our list of perfect squares. And the reason we pull it out is because it becomes 3. For the number 80, again, we're looking for the largest perfect square that pulls out of it. So if you're running through your list, notice that 4 does pull out of it. However, it's always a good idea to check to see if a bigger number does. And when you check, you will see that 16 and 5 also multiply to 80. Square root of 16 is going to give us 4. So that's going back to the basics of this. Now today we're going to do two things. We're going to investigate larger numbers and we're going to investigate variables. Now, one of the big things when we get to larger numbers, the first thing I would do is I would check to see, is that large number a perfect square? So for example, the square root of 900, if you type that into your calculator, it is actually legitimately just 30. So when you're dealing with big numbers where you may not recognize a perfect square anymore, my first tackle to that kind of problem would be simply type it in the calculator and see. So scooting over to the 700. So square root of 700 is not a perfect square. I got 26 point blah blah blah, all that number vomit. So I need to see what can I pull out of it. Now again, when you're dealing with larger numbers, sometimes it's difficult to tell the largest. Now this one, hopefully you can see the square root of 700, that you can pull 100 out of that. It is 100 times 7. And when you do that, well, square root of 100 becomes 10. So we just get 10 square roots of 7. So multiples of 25, multiples of 100, typically easy to see. But now we get down to that 1,568. So again, let's just type it in the calculator to see, is it a perfect square? Well, it's not. So now we have to start thinking, what can pull out of that? Well, notice it's an even number. So I'm going to take the 1,568 and I'm going to divide it by 4. So I break it down into 4 and 392. So at least I have a more manageable number now, okay? But now let's see, that 392, that could potentially still break down. It's still a rather large number. So let's divide that by 4. Well, actually, you can take another 4 out of the 392, and you're left with 98. Now that 98, now we're getting small enough that hopefully you can actually recognize that 98 actually is 49 times 2. So for these larger numbers, my tackle would be, if it's so large, you would have no idea what perfect square can actually divide it. Just start pulling it apart in pieces, okay? Because now you can see those pieces. Well, square root of 4 is 2. So, and I'm actually going to erase this so I can make myself more space. So we had 4, 4, 49 and 2. And again, the reason I was pulling out all those perfect squares is now this is 2, this is 2, this is 7. The square root of 2 is kind of our leftover. And remember yesterday we discussed, well, 2, 2, and 7, we're going to multiply those. So that gives us 28 square roots of 2. So again, larger numbers, don't be afraid to pull it apart by those means. Now, square root of 700 or 275. Anything that ends in 2 zeros, and a 25, and a 50, and a 75, that's going to be divisible by 25, okay? So I'm going to pull a 25 out of that. It is actually 25 times 11. So you get 5 times 11. So again, 25s and 100s are usually pretty easy to see. Now, square root of 10,000. You typed it into the calculator. Actually, that turns out to be a nice one. That turns out to just give you 100. And square root of 1,250, well again, it's a number ending in 50. So the first thing I'm going to do, I'm going to pull out a 25. And it turns out to be 25 times 50. Well now, notice that 50. Notice actually another 25 comes out of that. So you end up with 5 times 5 times square root of 2, or 25 square roots of 2 would be the simplified form. And again, this occurs when you're dealing with bigger numbers, that you can just pull it apart in pieces and then multiply all the pieces that you ended up pulling out. Now, let's take a look at our next bit. So our next bit is dealing with variables. So the square root of x squared. The square root of x squared actually just gives you x. A square and a square root undo each other. So whenever you have a variable squared, you can actually pull it outside of the square root as just the variable. So let's take a look at how to deal with examples like that. So the square root of 50x squared. So again, we have a number of 50. So hopefully you can see that that breaks down into 25 and 2. And now that x squared that's right there, I'm actually just going to pull that out as an x. I'm going to just pull it out right away so I don't even have to think about it being in the radical. Whenever you have a variable squared, just pull it out as the variable. So what do we get? Well, the square root of 25 is 5. So on the outside, we'll have 5x and then square root of 2. 72b squared. Well, 72, if you recall from yesterday, is divisible by 36. It breaks down into 36 and 2. And then again, notice we have that variable there, that b squared. I'm going to pull that out as just a variable, as just b. So now I have the square root of 36, which is just 6. So on the outside, I have 6b. And then on the inside, I have the square root of 2. All right, now for this next number, 735. This one might be a little bit trickier, okay, because 735, it's rather large, and we don't really know what perfect square may go in it. So I'm going to run through my list. 370 or 735 divided by 4, nope, doesn't work. 735 divided by 9, doesn't work. 735 divided by 16, doesn't work. Divided by 25, doesn't work. Divided by 36, doesn't work. Divided by 49, oh, there we go. I found one. 735 divided by 49 gives me 15. So sometimes you will have to search with a calculator to find what is a perfect square that goes into the number. Now, so we talked about it's going to break up, it's going to pull out the 49, and that leaves a 15. Now, that's just the number piece. Let's talk about the rest of this. So, for the rest of this, the first thing I'm noticing is that negative outside. Okay, that negative is still going to be there. Notice the x squared. That's going to pull out as an x. So on the outside, I had that negative x. Now notice the y. Okay, that y does not have a squared. So what that means is that y actually does not come out. That y has to stay inside the radical. All right, so when we're piecing this together, the square root of 49 that we pulled apart becomes 7. So outside the radical, we have negative 7x. But then stuck inside is the 15y, the pieces that could not come out of the square root. All right, so how do I know if I found the largest perfect square factor? So we're going to use 32 as an example. Now you've already seen how this works if you do it right. So doing it right would be breaking that apart into 16 and 2. So you get 4 square roots of 2. But let's say you didn't recognize that right away, okay? Let's say you just pulled out a 4. So you had 4 and 8. Well, the way you can tell that you missed a perfect square is notice that 8. That 8 also has a perfect square that can come out of it. It has 4 inside of it still. Square root of 4 times square root of 4, well, 2 square root of 2. So you can get to the same place. And you saw that when we were working with the larger numbers. However, it's still most convenient if you can pull out the largest one right away, right off the bat. All right, so thank you for joining me for this video. Now, again, as always, make sure you have all this written down, and then in class we will continue our practice work.